My name is Benjamin Wachter, and this is Lab 2 for Physics 2212. This lab expands upon our previous experimentation with induced neutral matter, specifically on a piece of tape that is induced with a positive charge, using a negatively charged piece of tape. Using Newton's second law of motion, as well as fundamental principles of electromagnetism to include the induction of neutral matter and the superposition of electric fields to represent evenly distributed charge on simple objects, like in this case a thin line, a model was created to better estimate the system of a piece of tape where the net force of gravity and electrostatic propulsion are zero. While last time the charge of the tape was calculated by assuming the tape was a point charge, the improved model considers the tape to be a linear object with evenly distributed finite charge. The data collected is as follows. The length of U-tape 1 was 0.2 meters. The length of U-tape 2, that is the bridge, was 0.214 meters. Because the density of the tape was 1 gram per meter, the mass of U-tape 2 was found to be 0.0214 kilograms. The distance at which the force of repulsion from tape 1 on tape 2 first started to act was 0.018 meters. Using the linear charge model, the charge Q was found to be positive 2.19046 times 10 to the negative 7 coulombs. The force of gravity was equal to the force of the bottom tape on the top tape, which was found to be 0.209934 newtons. Here, initial observations and calculations were recorded. It was determined that the U-tapes, both created from the same bottom tape, had the same charge. It was then determined that the charge was positive because it was attracted to a negatively charged pin. Furthermore, the mass of the tape was found to be 0.214 grams, and the charge of the tape, as if it had been a point charge, was found to be 2.75 10 to the negative 7 coulombs. Notice that this is different from the charge we find using a linear charge model. Here, using the charge of the tape as a point charge, the ratio of electron deficiency to atoms was found. Here is the new model coded in GlowScript for the linear charge model. The arrow in yellow represents the force of gravity acting on the upper tape, which is equal to the arrow in white, which represents the force of electrostatic repulsion from the other piece of tape. The arrow in white represents the superposition of all of the individual arrows that are green. These green arrows represent the force of one piece, the combined force of all the pieces of the bottom tape on that one piece of the top tape. Notice how their x components cancel out because of the symmetry of the system, leaving only one y component that we can say acts on the center of the tape. Using this model and comparing the force of gravity and the force of electric repulsion, the charge Q was found. Using the point charge model, the value of Q was found to be 2.5 times 10 to the negative 7 coulombs, whereas the line charge model yielded the value of 2.19 times 10 to the negative 7 coulombs. The value taken from the line charge model is likely more accurate, because it is a more accurate simplification of the real-life situation. In real life, rather than being a single point in space exhibiting a constant force, the charge tape is an uneven distribution of charge over an irregular three-dimensional shape. By treating the tape as if it were a one-dimensional line with evenly distributed charge, it is a step up from a single point charge, and is a more realistic simplification of the system because it makes less assumptions.